greater than. So the question is, will a solid form?
Yeah, no.
If you think a solid's form, give yourself 10 seconds to chat with your neighbor. If you think a solid's form, give me a thumbs up. If you don't think it's going to, give me a thumbs down. Will a solid form when you put these two things together? Okay, time's up. If you think a solid's going to form, give me a thumbs up. If you don't think it's going to form, give me a thumbs down. Down, 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 up, 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 down, up, 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 down, up. Looks like about 2/3 ups. It will form. A solid will form. Because basically what you were doing, remember that lab where we took the lead nitrate and the potassium iodide and we put them together and made that yellow gunk?
Yeah.
That's what's going on. You have a beaker of ions and a beaker of ions, and you're putting them together, and they're trying to basically all stay in the same beaker. What's happening is there's too many ions, and they're forming a solid that's going to fall out of a reaction. And that's what's going to happen here. If you take this and this and you put them together, you're going to have a QSP that is larger than the KSP, which means you are trying to cram too many ions into too small a space. So solids are going to fall out. Make sense? Now, if this value was smaller than your QSP, you'd go, nothing would happen. They stay dissolved. Make sense? Okay. That's level 2. Any questions? Are you ready for level 3?
Yeah, we should.
Give me a thumbs up, you're ready to move on.
Okay, John,
Okay. Okay, number 3, level 3 is coming over here. All right. So, strontium sulfate has a KSP of 3.2 times 10 to the minus 7. How much strontium sulfate can be dissolved in 1 liter of water? So, KSP is 3.2 times 10 to the minus 7, and that equals the concentration of our strontium, 2 plus, multiplied by the concentration of our sulfate, which is 2 minus. And again, if it helps, you can write the strontium sulfate dissolution equation, which is Sr2 plus SO4 2 minus. And in this case, it is a 1-to-1-to-1 relationship. Every time you put a strontium sulfate in water, you get 1 strontium and 1, that is a 2 by the way, not a 3. You get 1 strontium and 1 sulfate. Which means, if the concentration of strontium sulfate is X, what's the concentration of strontium?
X.
X. What's the concentration of sulfate?
X.
X. Question?
No.
Okay. Are we good with this?
Yeah.
Okay, make sure McKenna knows what's going on too. Or sorry, not McKenna, Elliot. Make sure Elliot knows what's going on.
No, I was like,
Yes.
I mean, I don't.
But yes, the KSP is a number, but we want to know how many grams we can dissolve. We're going to have to convert it. We're going to take our KSP, turn it into molarity, then to moles, then to grams. So, guys, important question up front. It's like, doesn't it just give us a KSP? It does, but our KSP is just an equation. We're going to take our KSP, we're going to turn that into molarity, turn that into moles, then to grams. So we want to know how many grams of this stuff could we add to 1 liter of water before it becomes saturated. Cool? All right. So what do I do?
That's a good question.
Okay. So we know that we want to know the concentration of strontium sulfate we can dissolve. But we know that this concentration is going to be the same as this concentration is going to be the same as this concentration. So this is just going to be, this number equals X times X.
So that number equals X squared.
Yep, so that number equals X squared. So X is going to be the maximum concentration of strontium sulfate that we can create. The maximum concentration and molarity that we can create. So what is that? So go ahead and solve for that.
Or
Square root, yeah. 3.2 square root of 3 feels like 1.8 or 1.9.
It feels like that.
That's why
I
you
got
got
5.6.
Oh, right, it's 10 to the negative 7.
punching numbers.
Yeah, 5.6, you're right. It's
So
square root.
the negative 4.
5.5 times
Or
5.5 is about 32.
I don't know.
I'm just spitballing here. You just don't do like there's a thing on the calculator.
Square the 3.2.
No, square root. So 3.2 times 10 to the negative 7 equals x squared.
Oh,
So you get the
okay.
square root of this.
Square root of 2.
Wait, so square root of what you get when you
Square root of 3.2 times 10 to the 7. So this is 3.2 times 10 to the minus 7 equals x squared. So x is going to be the square root of 3.2 times 10 to the negative 7. Cheer up, Mason.
Sorry. Okay, this is going to be really rough.
Probably gonna still be able to. The camera picks it up.
Yeah. It's one of those nose blows where you want to weigh yourself afterwards. Like, did I lose weight just now? Okay, so what is the square root of 3.2 times 10 to the negative 7?
5.6.
10 to the negative 3. And the unit is 10 to the negative 4th? 10 to the negative 4th. And the unit is molar. Goes because these are concentrations. So this is the maximum concentration of strontium sulfate that you can create. And we remember that molarity is what over what? Moles over liters. So it's moles over 1 liter. So it's Y moles over 1 liter. Even I can do this in my head. 5.6 times negative 4 moles of strontium sulfate, and we are 1 unit away or 1 exercise away from knowing how much we can dissolve. Strontium's thing out way over there. Strontium's mass is 188. What do you do? Guys, are you using your time wisely?
Yeah.
Are you an active participant in your learning?
I am. I was laughing at what you said earlier.
Okay. 184 is almost 200. So about 1, 2, negative 2, about 1 point something times the negative 2. Isn't that Bruce?
Not what I got.
I got .10.
What you get?
I just got
110? 110.
I got
Oh, you mean 0.01?
No, 0.1.
0.1. What you get?
I tried to be science. I'm sorry.
1 point.
Yes.
This is
0.10.
Times 10 to the negative 1.01?
No.
No,
It's
just
just 0.1.
Just 0.1.
Just 0.1. Okay.
0.1004.
Okay. 0.103 grams of strontium sulfate?
Yep.
Okay, that's it. So if you had a liter of water, you'll get 1/10 of a gram of strontium sulfate in there. Not much at all. We usually consider these kind of compounds insoluble. There isn't really like a boundary where it says insoluble versus soluble, but an insoluble compound is basically a salt that has a positive and negative that you just simply can't get much in there. It's like a few grains to get in 1 liter of water. Yeah, that's important. Okay, level 3 is done. Are you ready for level 4?
Yeah.
Okay, questions before we start level 4? Last one, here we go. Okay, so this is our most complicated one, but you can handle it. The KSP for iron 2 hydroxide is 8 times 10 to the negative 16. How much iron 2 hydroxide can be dissolved in 800 milliliters of water? Same system, but now we have a situation where we have FeOH quantity 2 in equilibrium with iron, which is 2 plus 2 hydroxides. Can you see how that is that? So iron 2 hydroxide is in equilibrium with the iron ion and 2 hydroxide ions. And since that's the case, the KSP is not a 1-to-1 ratio. Because for every X of these, are you paying attention? AJ? Yeah. For every X of these, how many of these do you get?
2.
You still get X. But how many of this do you get?
2x.
You get 2x. And this coefficient becomes a squared in the KSP equation. Okay. Can you see this? So, whereas before it was just x and x, now what variable do you want to put in here? X. And what variable do you want to put in here?
X.
No. 2x.
So it's 2x.
Yes.
Oh, wait,
Yep.
I see.
Because when you're dissolving iron hydroxide, 2 hydroxides are going to come out for every molecule of iron hydroxide.
How that's what the square was.
Yeah, it's kind of double duty.
Oh.
I know. It's kind of annoying, but that's the way it works.
How would you find the molarity?
So our KSP is 8.0 times 10 to the negative 16 equals, what should this be? X times 2x squared. 4x cubed? Yeah. Or x cubed. Or x cubed.
Does that say square?
Cubed. Because x squared, cubed, here.
I thought that was 2, sorry.
There we go. Cubed.
Okay, that's it.
So now you take the x, like just like before, solve for that x, turn it into molarity, turn it into moles, turn it into grams. You do pens. Profit. Still no bread.
Where? She did.
Where's the jelly?
She's right there.
Oh. I'm used to listening to
Cube root. 8, 4, 2, 120.
275.
122? 16 cube root. Wow, it's complicated.
87.5.
By the way, if you have a yellow calculator, there's a pretty cool key in there. It looks like this. It's like a square root with an n and an x. It's like a second something. It's kind of neat. You just make the n a 3 and you make the x answer. And then you can do a cube root. If you can't find your cube root key, you can also raise your answer to the 1/3 power. Another way to do a cube root is just to raise it to the 1/3 power.
In the normal calculators, you can click on math and you go down to the 4 5 minutes there.
or you can click on math and scroll down.
You should. Did you do it?
Yeah.
What'd you get?
5.3 times 7
Did you
Okay, did you keep in decimal?
That's what I did.
Oh, I square rooted it.
7 minutes left. So anybody have an answer for me? What do you got?
5.3 times 10 or 4.
Then the negative 4?
Yeah.
And our unit is molar. So then we're going to take this molar, realize that is moles per liter.
Oh no, that was like my final answer.
Oh, these are final time? Oh, you already did everything?
Yeah.
Oh, I got 5.8.
Oh, I got 10 to the negative 6 times 10 to the negative 6.
What do you do? What? That was the final answer.
Okay, the one that you wanted.
Oh.
6 times 10 to the negative 6.
Okay, so the one that I wanted here is 6.0 times 10 to the negative 6.
Yes.
And that's going to be molar. And then you're going to multiply that by 0.8. And you're going to get your 5.3 times 10 to the negative. Still no, 4, negative 4. Negative 4. Right?
I got negative 6. I got.
I'm sorry.
I don't know what's going
I'm
on.
so sorry.
Do I need to do this math?
I
Okay.
did.
Yes.
Okay, so before the cube root, I got 2 times 10 to the negative 16.
Yes.
Perfect.
And then after you cube rooted, I got 5.8 times 10 to the negative 6.
Yes.
Yes, that's good.
And I got
5.8 to the negative 6 molar.
And then divided by.
Then we're going to divide this to get moles. We're going to divide that by 0.8.
And you get 7.3 times 10 to the negative 6.
Oh, multiply by 0.8. Back up.
Oh,
Back up, back up. This is moles over 0.8 liters. So we're going to multiply both sides.
okay, so 4.7 times 10 to the negative 6.
4.7 times the negative 6 moles. And then you're going to convert that with a T-chart. And for every 1 mole of iron hydroxide, you're going to get so many grams of iron to hydroxide. Okay, and that's how much you can dissolve. Questions, queries, conundrums?
Are there cheat codes for the levels?
No, but you can buy loot boxes.
Nice.
Yeah, it's a form of gambling, though. You know, you might just get like a 1-star piece of junk, or you might get a 5-star. You never know.
But it's okay.
You might get a
It's for
5-star
kids.
hint or a 1-star hint.
Alright.
Damn EA.
Okay, questions? All right, there's one more thing to talk about. So math is done. This is just a what thing. There are special Ks. Just like there is a KEQ and a KSP, there are 3 other Ks you need to know. The first 2 Ks are acid and base equilibria. Okay. So an acid is like the hydrochloric acid we use. A base is like the sodium hydroxide we use. They're opposites. Acid and bases are opposites. So the special Ks are the acid equilibria, which is this, and the base equilibria, which is this. There's one more that's even more important. But just scribble those guys down. Special K.
Strawberry.
Dude, the red berries.
Definitely.
Oh yeah.
The red berries. They're not strawberries, they're red berries.
I think it has like
scary.
raspberries.
I was growing strawberries.
Yeah, it's whatever they squish together into and then evaporated.
I left strawberries. I mean, they kind of look like you're cut up and evaporated strawberries and stuff.
Most of them are. Honestly, I think it's whatever they got cheap that day. Whatever showed up on the truck.
Well, that's like meat.
Yeah.
Meat's disgusting.
Fish too. Whatever rolled into the dock that day.
I feel like that's what happened with the bacon. Why I'm fast food business on bacon right now.
Oh, that's exactly
There
what
must have
happened.
been too many pigs or something.
No, there was yeah, the whole bacon story, you can actually look it up. The whole bacon story was a big propaganda thing because there was parts of the pig that they couldn't sell. And so like how do we have all this extra like back bacon? I guess it's back bacon. We had all this extra back bacon. So what do? Well, we go to Carl's Jr. and we have them sell bacon burgers and make it really popular and make the bacon shampoo and bacon this and bacon that.
Yeah, you know, like the McRibs. They
Yeah,
only
people-
give that when it's cheesy.
Like everything has bacon now.
Yeah, it's a propaganda scheme. Okay, let's say bacon's really cool and everybody want to buy it. All right, so you learned in previous units that water, pure water, is a non-electrolyte, which means it has no ions. Turns out that's not actually the case. Something kind of crazy happens at the very, very small concentrations. When you have water molecules cruising around, sometimes they'll bump into each other, and one of the water molecules will donate one of its hydrogens to the other water molecule. And what you'll be left with is what's called a hydronium, and it's just H3O, and a hydroxide, which is OH. And it happens at extremely small concentrations, so small your little detectors don't even pick it up. But it's important because it's the basis for everything that is acid-base. And it's called the auto-ionization of water, where two water molecules can become a single hydronium and a single hydroxide. And the number is 1 times 10 to the negative 14th. Tiny, tiny number, but significant. Write that down. That's also a test question.
What is?
This, the auto-ionization of water, is 1 times 10 to the negative 14, and it's the concentration of hydronium times hydroxide.
Ionization of water.
Auto-ionization of water. It happens at extremely small concentrations, but it is the basis for all the acid-base chemistry that we do. Acid and bases are opposites. That's right. That's why if you get a bunch of pool chlorine, you put some drain on it, it's going to get really, really hot and boil and burn.
Let's try it. Are you a cereal boy?
No, I just want to see what
She's not a cereal.
She's gonna push the
She's
whole
working up to it though.
Yeah. Baby steps.
She's only 16. Give her some time.
I haven't had cereal in such a long time.
Okay, so that's it. Any questions?
Dexter, but
No,
that's
I'm
your-
totally.